Today we're going to talk about the missing value problem, and this is a problem on the SAT and ACT where you're given information about a set of values. Typically there's a missing value and you have to figure out what that missing value is based on the stipulations that are in the word problem. So before we get to the two techniques that we're going to use, it's good to have a quick review of mean and standard deviation. Mean is going to be given by the formula of sum of values over number of values. So given the set, let's say 75, 75, 75, the mean is going to be 75, obviously. Now the standard deviation in this case would be 0. And standard deviation, don't have to know how to actually compute it on the SAT or ACT, but it is how varied the set values are from the mean. Something like 75, 75, 75, well that's a 0 standard deviation. As the old joke goes, my head is on fire, my feet are on water, on average I am comfortable, right? On average he's comfortable, but the standard deviation would be very large in that case. So let's look at this set of values here through these two different methods. So first method is what I call TOPS total, where we are very, very focused on the sum of values. And with any word problem, we want to kind of treat it like a story and write it out and then use algebra to solve. This sum of values is going to be what kind of keeps us on the right path, as we'll see. This TOPS total, because this is the TOPS total. Now in our case here, this would be 225 on top over 3, 75 plus 75 plus 75 over 3. That average would be 75. So we're going to be very focused on this 225. So, and we will see when we manipulate the set. So let's say we were to change the first value from 75 to 100, the second value to 100 as well. I know that the third value has to equal 25 because the total in this set is going to equal 225 if I want this mean to remain at 75. So I didn't even have to, divide by 3 or anything like that. Or do any algebra. I know this third one has to be 25. Well, technically I did do algebra, but if this is x, then that's 200 and 225 minus 200. But that was really easy. Okay, let's move to the second method, which is what I call the gravity method, because we're going to be not thinking as far as this TOPS total, this 225, we're going to be thinking as far as the individual changes in each number and how they are going up or down. So gravity, what goes up must go down. So let's say we are to, again, increase this 75 to 100. So that is going to be plus 25. Let's say we increase the second 75 to 100 as well. That's plus 25. Now I get to my third and final value. If I want my average to remain the same, that means it needs to cancel out, which means the third value needs to be minus 50 to have this equal 0. Well, minus 50 from 75, that's 25. And I am left with an average of 75. And in this method, we're much more concerned about the 75 than we are concerned about this 225. We're not focused on the 225. I didn't add these at any point during this computation. Now this gravity method is going to be really, really helpful when it comes to changing the mean itself. So let's say instead of a mean of 75, I am changing it to, let's say, 80. Well, one way of doing that is just doing 80, 80, 80. And this will help demonstrate this point that I'm increasing each value by 5, plus 5, plus 5, plus 5. Well, you can do that by adding to each value, or you can do that by just adding 15 to one value. So in this case, let's say I add 15 to that first value, that's 90, and then I'm going to keep the remaining the same. So it's plus 15, it's going to be 90, 75, 75, it's going to be equal an average of 80. So this is really helpful. This gravity method is really helpful when we focus on the mean, and those should be whenever you see the mean in the problem, that's going to be what you're going to write down and focus on, as we'll see. Whereas in the TOPS total method, we're going to try to convert everything to TOPS total when we set up our word problem. Let's go ahead and look at problem number 1 from the SAT. the mean score of 8 players in a basketball game was 14.5 points. If the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. What was the highest score? So first method, I'm going to be thinking in tops total, which means we need to be converting everything into that sum on top. And it's going to end up with sum on top over the total number of values. So let's see our first tidbit of information. The mean score of 8 players was 14.5 points. Let's set up our formula. 14.5 equal x over 8. Okay, set that up. 14.5, let's solve for x. 0, 4, that's 36. It's 116. So I have x equal 116. I'm going to set this up at 116 over 8. Now, what did I do next? If the highest individual score is removed, okay, so I subtracted one score and then x, and what I'm doing here is really treating the numerator and the denominator as two separate problems here. So 116 minus x is going to equal something, and 8 minus 1 is going to equal something. Well, 8 minus 1 equals 7. Let's look at the remaining part of the question. The mean score of the remaining 7 players becomes 12 points, so we could do 12 equals 7 over x. X equals 84. So I'm going to put it like this. So in my problem, I have 8 minus 1. There are 8 scores. I took away 1. That equals 7. The important part for us, though, is going to be I have 116 points minus certain x. That's going to equal 84 points. And I could just solve for x. It's going to be 116 minus 84. 2, that's 32. And that missing score is going to be 32. So I map it out, keeping out for any and converting as possible to this tops total whenever I see the mean score of 8 players is 14.5. As soon as I see the mean score, I know that I have to convert it into the total points that they scored. The second method, the gravity method, we are way more focused on the mean, and I don't need to convert it, so it's a little bit easier in that regard. So the mean score of 8 players is 14.5, and the mean score of the remaining 7 players is 12 points. So I know that there's a difference in mean of 2.5 plus 2.5 in mean when I add that eighth score, that eighth value. So what is my baseline here? In other words, if I had 7 players and the mean is 12, and then I added another player and the mean did not change, what would that 8th player score? My baseline would be 12. But we increased from the baseline by 2.5, so as we saw before, that's equivalent to saying we increased by 2.5 points for each score. As we saw, we increased 5 from 75 to 80 for each for 3 scores. That's going to be 15 points total. So in our case, we increased 2.5 points for each score. That's 2.5 times 8. So that's going to equal 16. That's 20. You increased by 20 points. But that just accounted for the 2.5. That didn't account for the baseline. So you have to do 20 plus 12 equals 32. And that is going to be your answer, which is going to agree with what we had before in method number 1. Wonderful. Now, I would not necessarily do this method on the test number 2, second gravity method, but it is important to understand how this increase in each value works and translates to a difference in the mean. Okay, let's look at the second problem. This is a really, really good problem, definitely a trickier one on the SAT. Okay, and let's go through it, keeping in mind when we're doing the tops total method, we need to convert to the total value, that tops total, that sum, and when we're doing the mean method, the second gravity method, we're thinking in terms of the mean. Okay, so tops total hat on. An online store receives customer satisfaction ratings between 0 and 100. In the first 10 ratings the store received, the average of the ratings was 75, so I'm just going to write this down like that. What is the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? Okay, I see 85 for the first 20 ratings. I'm just going to write that down as well. Do the math here real quick. 10 is going to be 1,700. over 20. 85 versus 20. So now I've converted the information in the problem. We can get to what the problem is actually asking. What is the least value the store can receive for the 11th rating, still be able to have an average? So really what we're asking about is what is the least value that they can have for the 11th rating and still have whatever we're missing here, and still have whatever this value of the second 10 numbers has to be. Well, what does the second 10 numbers have to be? If you want an easier way to do this, you think as far as the denominator first. So 10, this has to be 10. Now on right to equal 20, and on the top on the numerator, I don't know what this value is, but I do know that it has to equal, this has to make sense, this is the first 10, this is the second 10 values, so 1700 minus 750 is going to equal 950. So I know that 950 over 10, this is what the second 10 values looks like. And now I could proceed to the second part of the problem where we're asking what is the lowest value you can get for the 11th rating and still be able to have an average. So I need, in other words, I need 9 values here that are going to maximize and 1 value that is going to minimize, and it's going to equal 950 total. Well, I can do that as follows. 900 over 9, because maximizing is going to be 100, plus x over 1 equal, and I have this over here, 10 over 950, so x equals 50, and that is my answer. Again, what we did is we used this method to set it up, number one, in step 1, and then we use the same thing to set it up in step 2, where we're just really thinking about what's on top and using potentially these numbers on bottom to set up the problem if we're having a problem doing that conceptually. Method number 2. Now, it's broken into 2 parts, just like method number 1. Part number 1, I think, is a little bit easier to see, and then part number 2 is going to be a little bit more challenging. So let's think about it. Again, gravity method, we're thinking about the mean. We're not thinking about this total number on top. So in the first 10 ratings the store received, the mean, so as soon as I see mean, alarm bells are going off, was 75. All right, 75. Able to have an average, also mean alarm bells, of at least 85 for the first 20 ratings. So my total average is 85. That means that this 75 for the first 10 was minus 10. So the average for the second 10 has to be plus 10 in order for this to even out to 0, which tells me plus 10 from 85, which is the overall average, means the average for the second 10 needs to be 95, or 10 plus the average, the total average. 95, let me put the problem back. So now, what is the least value the store can receive for the 11th rating? Again, we're going to try to maximize 9 of the values in order to minimize that final value, but this time we're going to do it as far as not the total, but the change from the mean. Well, if we increase 9 of the values to 100, that means that's plus 5 from the mean of 95 for the second set of 10 values. Well, 9 values with a plus 5, that's going to equal a 45-point increase. Plus 45. Well, now I have my final 10th value, and overall it has to zero out, so that means that 10th value is going to be a minus 45. Well, what is the overall, the mean for the second set of 10 values? That's 95. If I subtract 95 minus 45, that's going to equal 50, which is the right answer and agrees with what we got here. Now, I don't know if I necessarily would do it this way. I think the first step is easier to see. The second step is a little bit trickier. I'd probably just do it this way on the actual test, which is going to be much more straightforward and simpler and less prone to any sort of just conceptual error. And just overall, this first method is really, really good to have in your back pocket, because on the SAT, we don't want to be reinventing the wheel. We want to do things that we know about and are just, they might take a little bit longer, but are predictable and not subject to any of our careless mistakes or their tricky phrasing or whatnot.